In this section, we want to look at some of the factoring that you've done before and then have a couple of new kinds of factoring that we're going to do. So let's look at our first problem. I want to factor 4y to the fourth minus 12y squared plus 9. And what I notice is the first term is a perfect square. It's 2y squared quantity squared, and the last term's a perfect square. So I'm going to see if this factors as a perfect square trinomial into a binomial squared. If it does, it would be 2y squared minus 3 quantity squared. So all I have to do is check this first term, 2y squared quantity squared, is 4y to the fourth. 3 squared is 9, so that works. And now this middle term, let's just see if it's twice the product of these two terms. 3 times 2y squared is going to be 6y squared. Doubled would be 12y squared. And then the sign is correct there with the negative sign. So that is how that factors. Let's look at another problem. We have 64 minus t squared. Okay, again, I see that this is the difference of two squares. In this case, this is 8 squared and t squared. So this should factor into 8 plus t times 8 minus t. So I see this time I have the difference of two squares. So a couple of the kinds of factoring that we've done before with a perfect square trinomial and then the difference of two squares. The next problem I want to look at is called the difference of two cubes, and we haven't done this type of factoring before. So let's take a look. X cubed minus y cubed. In this case, we have just a formula that we use to factor this. So you have to memorize it, and it looks like this. The difference of two cubes, x cubed minus y cubed, is going to factor into just the difference of the two numbers, x minus y, without the cubes, times the square of the first term, change the sign from minus to plus, multiply the two terms together, xy, and then add on the square of the last term. So that's how the difference of two cubes factors. X cubed minus y cubed is x minus y times x squared plus xy plus y squared. Now, if you want to prove this to yourself, what you have to do is multiply this back out. If you do that, you'll see you'll get exactly x cubed minus y cubed. So once you've done that, convinced yourself that that is the correct factorization for x cubed minus y cubed, the next thing to do is just memorize it. Let's look at another one. Here I have the sum of two cubes, a cubed plus 2 cubed, because 8 is 2 cubed. So if I want to, I can rewrite this as a cubed plus 2 cubed, just so we can see it. Now I'm going to apply the formula that I've memorized from the book for factoring the sum of two cubes. So first of all, I just write down the two terms without the cubes on them, a plus 2. Then I multiply by the square of the first term, a squared. I change this sign to minus, multiply them together, 2a, and add on the square of the last term. 2 squared is 4. Now again, that's a formula. We have to have memorized that formula, but that tells us how to factor the sum of two cubes. So a cubed plus 2 cubed always factors into a plus 2 times a squared minus 2a plus 4. Now let's go on and look at a couple of other problems. Problem 5, I have 10 r cubed minus 1250. So I don't recognize this as a perfect cube, but I see that I have a 10 common to each term. So I'm going to begin this problem by factoring that 10 out of this term. What's left is r cubed. And when I factor 10 from this term, what's left is 125. So I see I have the difference of two cubes, r cubed and 5 cubed. So I'll factor using my formula. I want to keep my factor of 10, so I'll just leave that right there. This is r cubed minus 125, so it's going to factor into r minus 5 times r squared, plus, I just multiply them together, 5r, and then plus 25. So to do that factorization, you have to have memorized the factorization for the difference of two cubes. X cubed minus y cubed is going to factor into x minus y times x squared plus xy plus y squared. And again, to convince yourself that this works, multiply these two things out, you'll see you'll get exactly that. Here's another problem. X squared plus 49. Okay, this is now the sum of two squares, x squared plus 7 squared, and the sum of two squares never factors. So I'm just going to say that this is prime, because it has no other factors over the real numbers than what's right here. So the difference of two squares always factors. the difference of two cubes always factors, and the sum of two cubes always factors, but the sum of two squares never factors. Here's another problem. Let's see, what do we have? X squared y plus 3y plus 2x squared plus 6. Okay, I see I have four terms right here. So I'm going to try to apply factoring by grouping. I'll group these first two terms together and see that there's a y common to each one. I'll factor that out. I have x squared plus 3. And then I go to my second two terms and I see they have a 2 common. I'll factor that out. And what's left is also x squared plus 3. Now the x squared plus 3 is common to this term and this term, so I'll factor it outside. X squared plus 3 times what's left in this term. When I factor x squared plus 3, what's left is y, plus, that's that plus sign. What's left in this term when I factor out x squared plus 3, which is 2. So that's factoring by grouping. I have the four terms right here. It looks like factoring by grouping. I group the terms two at a time, factor what I can out. Once I've done that, I look and see if there isn't something else common to each term. If there is, I'll take that outside, which I did. So this factors into x squared plus 3 times x plus 2. Remember, you never need to make a mistake with this factoring because you can always multiply your factors back out and see if you don't get what you started with. Here's another problem. 16 minus x to the fourth. I see that that is the difference of two squares, 4 squared and x squared squared. So I'm going to factor this into 4 plus x squared times 4 minus x squared, just like I always do when I have the difference of two squares. This is 4 squared, this is x squared squared, so it's 4 plus x squared, 4 minus x squared. Now, just like we said before, the sum of two squares never factors again, so I'll just leave it like that. But the difference of two squares always factors, so that will be 2 plus x, 2 minus x. Now, when it comes to trying to factor the sum of two squares, if you think that the sum of two squares factors, go ahead and write down what you think the factors are, then multiply them back out. You'll see that no matter what you write down for the factors of 4 plus x squared, the sum of two squares, you can never multiply those back out and get 4 plus x squared. There are no factors for that. It's factored completely as it is. One more problem. 8 minus 14x minus 15x squared. Okay, I look at this and I see it's a trinomial. I'm just going to see if I can't factor this into the product of two binomials. I see that there's no common factor for these three terms right here, so I'll just factor whatever I can. Let's try 4 and 2, because 4 times 2 is 8. And let's try 3 and 5. Oops, I'll take that back. Let's try 3x and 5x, because 5x times 3x is 15x squared. Okay, let's check our middle term. Multiplying here, I get 6x. Multiplying outside, I get 20x. 6x and 20x differ by 14x. So I make the 20x negative and the 6x positive. When I multiply these out and add, I'll end up with negative 14x. Let's just check our first term. 4 times 2 is 8. Our last term, positive 3x times negative 5x, negative 15x squared, and then I know that the middle term works out. So that's one of the first kind of factorings that we did, factoring just a regular trinomial. So that's a review of all the types of factoring we've done before, plus factoring the sum and difference of two cubes. What you need to do with the sum and difference of two cubes to be able to factor them is memorize those formulas that you see in the book.